My name is Michael, and I'm here to present our work on semantic similarity in video retrieval. This was a collaboration with myself, Hazel, and Dima here at the University of Bristol. To start with, let's define the task of video retrieval. Given a query video, find the corresponding caption. In this example, a man is peeling fruit carefully and neatly is the ground truth caption to retrieve. When we look at other examples within the dataset, we see two main issues. Firstly, only a single caption is considered as ground truth, even when other relevant captions exist. And secondly, captions which are completely irrelevant are treated in the same way as those which describe the video. This is due to the assumption that current methods make. There exists only one corresponding caption for a given video. We find this is the case for YouCook2, where we show the ground truth caption in bold, as well as for MSR-VTT and EPIC-KITCHENS. We investigate all three in this paper, uncovering the issues of the instance-based assumption for both training and evaluation. To begin with, we first explore the issues of evaluating using the instance-based assumption. We find all captions that are relevant, and then evaluate using the highest and lowest ranking examples. This gives us the best and worst case performances for each method. On YouCook2, we see that two recent works, MOEE and CE, perform comparably, although they have a very large range of performance. We find this is also the case with MSR-VTT and EPIC-KITCHENS 100. In this paper, we introduce semantic similarity for video retrieval, and we have two main goals for this. Firstly, we want to move from a one-to-one relationship between videos and captions to a many-to-many relationship. And secondly, we want to allow for differing levels of similarity between videos and captions. However, annotating many-to-many relationships is too expensive. Instead, we introduce the notion of using a proxy function. To do this, we first assume that caption sufficiently describes the video it was collected for, and that allows us to define a proxy function that relates two captions, allowing us to relate a video with a different caption. In the paper, we introduce 4 proxy measures based on bag of words, parts of speech, synsets, and meteor. We show several examples of how these proxies compare to each other and the emphasis they give to actions and objects in the captions. To evaluate semantic retrieval, we use the normalized discounted cumulative gain metric. This allows us to evaluate multiple relevant items with differing levels of relevancy. Evaluating with semantic similarity shows differences when evaluating with instance-based retrieval. On the left, we see that current methods MOEE and CE outperform the simple MME baseline. However, in the 4 cases on the right, when using the proxy measures, we see that for each case, the performance is comparable. Next, we discuss how to train with semantic similarity. But first, let's go over instance-based video retrieval training. This uses a triplet-based learning objective and ensures that the distance between the query and a positive is smaller than the distance between the query and the negative for all negatives within the batch. When we move to training with a semantic similarity, we first choose a threshold. This allows us to create a set of positives of all examples above this threshold. During each epoch, we sample a single positive and then apply the loss as before, ensuring that each positive is closer to the query than every negative within the batch. We can see the results of training for instance-based retrieval in black and show that for most thresholds, training with semantic similarity outperforms instance-based training regardless of which proxy measure is used. So, to conclude, current approaches only assume a single caption is relevant for a video. We find that this assumption breaks for all popular video retrieval datasets. And to overcome this, we propose semantic similarity for video retrieval, which allows for multiple relevant items with differing levels of relevancy. Thank you for watching. For more information, please come to paper session 3 during CVPR or visit the webpage listed. Finally, we include the GitHub repo, which includes code for training and evaluating your methods for the semantic similarity video retrieval task.